guys, I hope you are having a very great weekend. And today we are doing a very interesting question, a question that is considered very hard actually, detecting graph in a directed cycle in a directed graph. And this is actually very interesting. There will be very interesting edge cases that you'll have to think of. And thank you so much for showing up on a weekend on a Sunday. We did a live on main channel, and that is why we had like a 1 day gap because we were live on main channel. So I figured that you guys would want to be there. So yep, and today we are going to be discussing this question. So I wanted to start thinking about it, start thinking of various edge cases that would be there when detecting a cycle in a directed graph. What would be the difference when we think about a directed graph and an indirected graph, right? So we have to think about that also. So I am just trying to connect my iPad. Okay, and once we do that, let's get started with drawing the diagrams and trying to figure out all the edge cases that we can think of. Okay, so you can see my screen and hear me properly, right? Can one of you quickly confirm that you can see me, you can hear me? Yeah. Okay, great. So we are going to, thank you Shivai, thank you Sampath. So what we are going to do is we are going to just start drawing some nodes and see that when is there a cycle in a directed graph. So when we say about a directed graph means there are going to be arrows, like there will be parents and there will be children, right? So suppose this is a graph. Is there a cycle in this graph, guys? Come on. So this is like this. There is no cycle over here, right? But the moment I draw the graph like this, there is obviously a cycle over here, right? So we have to think of when there will be a cycle and when there will be no cycle. So to make it easier, let me just tell you that we are going to be using DFS to detect the cycle. Okay. Now there are a lot of edge cases in this, and that is why I don't want to make it hard for you. I don't want to use a lot of technical terms also to make it hard for you. So let's just try to keep it very, very simple. So when we do DFS, what do we actually do? We go depth first, right? So suppose I'm starting from here. So I go like, okay, so this is my first node that I visit. This is my second node that I visit. Now from here, which is the third node, this is the third node. From here, I go back and I end up visiting one again. So basically, I'm saying if I visit a node again while doing DFS, that means I am in a cycle, right? That is what we used to do in graphs. So what was the difference between DFS or BFS in a graph versus in a tree? That we can be visiting the same node again and again, right? So if we are visiting the same node again, it essentially means that it is a cycle. Now, it might seem like this is a very simple thing, but when we start looking into edge cases, there will be one or two very, very tricky things. So stay with me. Now, first thing that I want to make very, very clear is that, if we are visiting a node again, I am saying that this is going to be a cycle. Now, this is the first statement that I'm going to make. Now, I wanted to think about it. Is this statement always going to be true? I'm going to prove that this is not always going to be true, but let's take some examples to understand that why this is true after all. Okay. So suppose this is one node. I go like this and I start visiting like this. Now I visit this. From here, I go here. From here, 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 here. I come back here. So again, I'm visiting the same node two times. So there is a cycle, right? So till now, this seems to be the right statement that I have written, right? Now there's another tricky statement that I'm going to say, that we will have to use DFS multiple times. Why am I saying multiple times? Now let me take a few examples. Okay. Now suppose this is a graph. This is a graph, right? So if I start visiting from here, suppose the nodes are 1 2 3 and 4. Now suppose I start visiting like this, what is going to happen? I visit this, then I visit this, right? Now I visit this and I visit this again. So I visited 4 two times, right? So okay, so is does that mean that there's a cycle? Now there's a problem over here, right? So there's what problem is over here? We are going to discuss this also. So we have to think of all the edge cases. Understand? Okay, now let's think of more edge cases. Now suppose this is the case that okay, let me take another example. Now if this is a graph and I start my DFS from here. So I visit this. Suppose this is 1 2 3 4. I visit this. Okay. From DFS, I will come here. I'll mark this as visited. I come here. I mark this as visited. Right. So, okay. I started from my node 1. I visited 1, 2, and 3. But I never visited my node 4. Now what is going to happen? I'm not visited my node 4. So what if there was like a cycle over here and I started my DFS from here? Obviously I'll end up missing the cycle, right? Do you understand? So I can't just pick any one random element and do DFS on that element. I have to make sure that I'm visiting all the elements. That is why I'm saying that we will have to use DFS multiple times. Let us take more examples to understand this particular point, that why am I saying that we would have to make DFS multiple times. Now suppose there is one graph like this. You see, I'm taking random graphs. It's not like I've thought of some examples and have come in front of you. So you should also take various examples to really understand at what is happening. Now, suppose this is another graph, okay, and it is like this. And suppose there is a cycle over here. Let's say there is no cycle over here. So this is not there. Okay. Now let's start visiting the nodes again and again. Suppose I'm starting my DFS from here. I visit this. I move on to over here. I visit this. I move on. I visit this. I move on. I visit this. I move on. I visit this. Okay. DFS is what? Depth first search. I'm going to visit all the adjacent elements first and then come back. So I come back, but there are no nodes to be visited from here, no nodes to be visited from here. So I'm not visited these. I'm not visited this also, and there's a cycle over here. So I end up missing. So what am I going to do? These are already visited. So what I will do, whatever were missing, like from here, I'm going to try and checking DFS again. From here, I will start checking DFS again. From here, I will check DFS again. So DFS multiple times on not unvisited nodes. You realize? So the visited nodes I've already checked if there's any cycle from those nodes, but this ones I have not checked, right? So we have to also check that there are any cycles from the unvisited node. So that is why you have to do DFS multiple times. Have you guys understood this much? This is the second point that I want to talk about. Come on, I need you to confirm that you have understood why we are doing DFS multiple times, basically on all the nodes that are not visited. Okay, so that is one thing. Now, next third point that I'm going to say is the example that we had taken earlier also. Okay, great, Sampath. Thank you for confirming. Thank you, Mansoor. Okay, so what we are going to do is take one example like this. So suppose these are the nodes 1, 2, 3, 4. We were doing what? We were marking nodes as visited. Now I start from here, I mark 1 as visited. I come here, I mark 2 as visited. I come here, I mark 4 as visited. Now these are visited, right? Now what am I going to do? I'm going to going back my depth, and then I'm going to visit 3. Now this is visited. I come back and I see that I've already visited 4. So I'm going to say there is a cycle. Because what is the check? That if I'm visiting a node again, there's a cycle. This was the condition that we said, but now I am saying it is not true. Okay, can you see the problem over here? I'm visiting the node again, but there is no cycle. There is no cycle, right? It is like this and it is like this. So there is no cycle. It's not like it's connected like this or like this. It's not a cycle. Are you able to understand this point? Let me show you that same graph again. So this is basically 1, 2, 3, 4. I visit this and I visit this. So I'm visiting 4 two times. So I'm saying that there is a graph, but there's a cycle, but there is no cycle, right? So what can we do over here? We have to think about that. Now, what I'm saying is that instead of just maintaining one structure, one visited array, what am I going to do is I'm going to store two arrays. One is the one that I have visited nodes, and one is the one that I'm saying visited while recursion, or I'm going to say current visited. Stay with me, guys. First, I said that if we visit a node again, it is a cycle. Second, I said that we have to do DFS multiple times, basically on all the non-visited nodes. Third thing that I'm saying is that we have to we have to not only have one structure called visited, we also have to have another structure called current visited. Now, let me show how this is going to help us. Now, this is visited, this is visited, this is visited. So this was one set of recursion. When we go back, what I do is, so there are two structures. One is visited and one is currently visited. So when I start marking these, let me draw the diagram again to make it very, very clear. 1, 2, 3, and 4. So there are two structures now, visited and currently visited. Okay, currently visited means in that recursion call, in that recursive call, are we visiting the node again and on? So I start from one. So in my one, so there are four nodes, right? One, two, three, four. Let's mark them like this. Okay. So this is how our structure is going to look. So my one, I start from one, I visit it, right? It is also my, sorry, it is also my currently visited one. So I mark this and I mark this also. Then I come to 2. 2 is visited, currently visited. Then I come to 4. Now 4 is visited, currently visited. Now what do I do when I go back? That recursive call is finished. So in the currently visited, I make them as false. I mark this again false, mark this again false. I come back over here. Now my 1 is still in current visited. I come back to 3 and I mark this as visited and currently visited. Now when I come to 4 like this, I see that although this is visited, it is not in the current recursive stack. So because it is not in the current recursive stack, it is not resulting in a circle. It is not resulting in a cycle. Do you understand the difference between visited and current visited? Visited can happen that, I went like this and I visited it, but it should be in the current stack. So basically, if I'm visiting the same in the same calls, now like I visited this via 2, right? But now I'm visiting this via 3. So that should not be a problem. Have you understood? Guys, I need you to confirm that you have understood the difference between visited and current visited. Okay, this is a very good example that you should take to understand why we need another structure current visited over here. We are basically doing DFS multiple times, but we are also making sure that, when we are visiting the node again, we know that it is because of the cycle. So Mansoor is saying, so we need to use the backtracking template. Exactly. So here we are seeing that in the current recursion call, if the node is being visited or not. Okay, so if we didn't have this current visited, just take example of this particular example and you will be able to understand that how, it is leading to a true, but it should be a false. Because this is not a cycle, the example that we have taken, but it is going to return true if we don't have this current visited with us. Okay, have you understood, guys? Can we go ahead with the code? So these are the Sampath is saying, so yes, we are checking in the current path, same node coming again or not. Very good, Sampath. So these are the three important points. First, we are going to check whether we are visiting a node again. So there will be a cycle. But we also have to check that, okay, is it in current visited or not? Okay. Third thing that I'm saying, the second point that, okay, DFS, we are going to do multiple times on all the unvisited nodes. Okay. So Shivai is saying in one single visited array, we can also take 0 for unvisited, 1 for currently visited, 2 for already visited. That is also one way to go about it. But here, basically, I'm going to keep it very simple and have two Boolean visited and currently visited structures. So it is going to become more clear. Understood, guys? Yeah. So now let's get ahead with the code and the example. Can one of you quickly confirm that you're able to see the question and the code part and you're able to hear me properly still? Just confirm that. So this is the question that we are doing, detect cycle in a directed graph. So here you can see that we are given this example 0, 1, 2, 3. See in these, thank you Shivai for confirming. So here you can see that because we have to just detect a cycle, there is no starting point. You remember when we used to do like DFS or just BFS, you just have to go through a tree. We were given a starting point. There is no starting point over here. Like suppose I end up starting from 2. Suppose this was 0 and I'm starting from here. I will end up visiting just this part. I will not end up visiting this. That is a second point that we have to do DFS multiple times. So that is the different thing over here. Okay. So what are we going to do? We are going to have two vectors, Boolean vectors. One I'm going to call as visited. What is the size? That is V. I am assigning initial all as false. So we have not visited anything. And similarly, again, we are going to have current visited. And again, everything is false. Okay, we have seen in previous questions that we have done. So this is adjacency list. Again, number of rows is V, that is basically number of vertices. And this is like number of columns will vary depending on the number of edges that are there. Okay, so now you should be completely comfortable with the adjacency list at least. What do we have to do? We have to again and again do DFS for all the nodes, right? So what am I going to do? I'm going to go through all the nodes. So for int I equal to 0, I is less than v. So basically I'm visiting all the nodes again. So I'm reading the comments, guys. So if you have any doubts, you can ask me. Okay. So what do we have to do? We have to do DFS on each and every node. But I have to do DFS on which nodes that are not yet visited. If it is already visited, why do I need to check DFS again, right? So only if it is not visited, the nodes that were missed in the previous DFS, that we have to check. So if it is not visited, what am I going to do? I am going to DFS. So I can call this function anything, helper or anything. So what all things will we need to pass to it? We will need to pass the visited. We will need to pass the current visited structure. We will also have to pass the adjacency list and the current index which we are going to deal with, right? So we are going to write this recursive function. And what are we going to do? If there is no visit, if it is not visited, we will do a DFS and it is going to return a value. If it returns a value, basically we are going to check, or we can also call it is cyclic util or helper. Basically, it is going to return true or false. So if this returns true, basically if there is a cycle, we are going to return true. Otherwise, we are going to just get out and return false. This much is clear. So we are going to check if it is not visited. We are going to do DFS over there. If that returns true, basically if there is a cycle in that particular DFS, we are going to return true. Otherwise, we are going to get out and return false. Okay. Now what do I do? I implement this DFS function. So what have I passed? I have passed vector of bool. I'm going to pass it as reference because I need the values to change. Very important point, guys. If you should be able to remember this now, that we always have to pass by reference. Otherwise, you won't be able to see the values that you have changed, right? Okay. I am guessing you won't be able to see after this. So current visited, then vector of int, and this is the adjacency list and the index. I do not think that we need the v value. If we will need, we will pass that as well. Okay. Do you think we will need the v value, guys? Do you think so? Let's see. So first thing, once I get in the recursive call, what do I do? Wherever I am at, I'm going to first mark it as true. I'm going to mark the visited as true. Because I'm in the current visited wala thing, I'm also going to mark it as true. Okay. The only difference between visited and currently visited is once I am done visiting all the adjacent elements of this particular element, the current visited, I am going to mark it as false when I am getting out. Do you understand why am I doing this? When I go back the recursive call, when I am backtracking, I need to mark them as false. I mark them as visited when I'm coming. Current visited also true, true. When I'm going back, I have to mark them as false. Have you understood this, guys? So this is the difference between visited and current visited. I am not going to mark anything as visited as false, but I'm going to mark current visited as false because I'm done with that depth. So I'm going to go back. I'm done with that branch, so I'm going to go back. Have you understood this? Okay. And so what am I going to do? I'm going to check for all the adjacent elements for index. So for int x, so basically for all the adjacent elements to the index one, what am I going to do? I'm going to check if that particular thing is there in the current recursive stack. First thing that I have to do is return true. So if it is then in the current stack, I'm going to return true. Okay, but if it is not in the current stack, then I will go ahead and I will check that if there is no visited node, if the visited is not there, then I'm going to do DFS on the adjacent element also. So what am I going to do? In the adjacent element, I'm going to say visited. I have to pass current visited, the adjacency list, and the new index is going to be what it is going to be index. So now if that returns true, if there is a cycle within that adjacent elements, I have to return true. Otherwise, I'm going to get out and return false. Any doubts, guys? Anything that we have not understood? Come on, I know this is a hard question. The edge cases are a lot. You have to confirm and tell me that you have understood or not. What have I missed? Int x in the adjacency of index begin was not declared. Okay, guys, what is the mistake? Helper. Oh, helper. Sorry, DFS. Thank you. I'm used to calling it helper. Okay, great. Let me just compile this. Okay, this shows that you guys are actually here, but the mistake is over here. So it is saying for int x in adjacency of index. So for this, I am going through each element, right? So what is the problem? For int x, guys, I need you to tell me what is the problem. In the adjacency of index, I'm going through each element. I have passed vector of integers. Oh, I have not passed the array. Sorry, I have just passed the first element of the array and not the entire array. So that will be a problem. Let's try to submit this. So we can always end up having a lot of issues, right? So, yep, you should be able to debug these problems. If I make mistakes, you will not make those mistakes when you practice. Okay, so all the test cases passed. Good. Also, the link is in the comments. So, go practice all the questions that we are teaching, that I'm teaching, because it is just not hearing and understanding the edge cases. You should be able to think of themselves yourself. Okay, and also, guys, so tomorrow we are going to be doing the question that direct cycle in undirected graph. So we will understand how directed and undirected is different. Here, okay, just think about it a bit before we start looking at tomorrow's question. I will again schedule the live for sometime in the evening. So do show up. We will understand how the it is going to be different for directed and undirected graph. Okay, let's quickly look at the time and the space complexity also. Basically, here we are doing DFS and we are visiting all the elements once, right? We are doing DFS multiple times only if the node is not visited. But again, we'll end up visiting the nodes only once, right? So space complexity is order of V, because what is the maximum recursive stack? What is the maximum size of the recursive stack? It is going to be order of V. Time complexity, we are visiting all the nodes once, so order of V plus C. The same for DFS, BFS. If you are using DFS, BFS for detecting cycles, it is going to be same. So I hope you understood the question properly and I hope you had a good time. Thank you so much for showing up and I hope you are going to show up tomorrow as well. Okay, see you. Bye.